Okay, hi guys. This is actually my first time speaking in a meetup, and especially for like a large audience, since I think the graduation ceremony in high school. So be nice. Like I'm a data scientist at Argmax. This is Uri Oringen company. He's going to be the next speaker, so I'll let him to do the company overview speech, whatever. So we'll start. So the agenda for today will be a project overview that we will talk about in a second. At Argmax, just for like in a one sentence, it's a project boutique consulting projects company. So startups and large companies are coming to us and asking for help for some data science projects, and we help them. We specialize in recommendation engines for the ad tech industry or content, similarity search, stuff like that. So we're going to talk about the project. We're going to talk about how we measure diversification. So you're going to understand the context in a second. We're going to talk about color diversification, color spaces, triadic and complementary colors. Everything's going to be clear in a second, I promise. And a summary. So my talk is a relatively short one, so we're going to do it fast and high level. So this is it. So the problem overview, can you hear me? Yeah? Okay. So you guys know Artlist? Yeah? Okay, so Artlist is how I said that? It's a high quality stock content hub. Okay, so if you're like a content creator, a filmmaker, a social media influencer, you can subscribe to their application and have access to really high quality content and music. So you can download footage, you can download music, sound effects, stuff like that. So Artlist approached us to create a recommendation system for the footage section, which you can see here. So currently what Artlist do is creating a unified, they call it top 200 footage recommendation, which is not personalized. So all users can see the same feed, which you can see here. And they wanted to take it a step further to make it personalized. So we are creating currently a footage recommendation engine, but there was one thing that we needed to take care of. Like regardless of the recommendation engine that generates candidates, the Artlist have like a visual policy, we'll call it. Okay, so they have like a visual policy that says, if this feed is good enough, visually appealing enough, beautiful enough, which is hard to measure. So why do we consider some feeds to be more visually appealing than others? That's a question we asked ourselves before like approaching this re-ranking section of the recommendation engine. So we have candidates, now we need to decide if the first 6 recommendations together are visually appealing enough. Okay, so this is like a few themes or categories we can think of when we trying to answer this question. So frame type, if it's close up or long shot or medium shot. The composition is like, it's a 3/3 rule, right? If it's on the left side or the right side. The category is that animals, if all the feeds is really, if each of the personalized recommendation is animals. Each of the footage is an animal, and it's really beautiful by itself, but we can't show them all together because the diversification of such feeds is going to be boring. The object inside, so if it's an animal, it's a plane, it's just a landscape.
Did you have a list of categorized footage which you knew those were the blockbusters, those are the best footage, and then you trained your model in order to match them?
Yeah, so actually we have, there were 2 approaches. We're not going to talk about it right now because it's out of scope, but we have a collaborative filtering recommendation, which takes downloads and other user downloads into account. We have content-based, which takes more the history, like the content history of the exact same user without like looking at relatives there, and a hybrid approach. But
again, I'm talking about.
Yeah, we have everything about the footage. We have everything. We know how many times it's downloaded and how many users and time, whatever you want. But we're not going to talk about right now. We're going to talk only the last part of the recommendation engine, which is re-ranking the already personalized and good recommendations. So, but how can we get the best representation of footage colors? Okay, so I'm sorry, I didn't say. We're going to talk only about colors right now in this talk, okay? So how can we get the best representation of footage colors? This is another question we asked ourselves. So like a very naive but yet powerful approach was say, okay, color histogram. We can calculate the histogram for footage, right? And then we actually get an embedding for such image, right? Like exactly like other embeddings of really good and sophisticated deep learning models, we can get an embedding space for images using histograms, which the embedding space is like capturing the essence of colors, only colors, not subject, not anything else. This is exactly what we wanted because we're in the last phase of recommendation right now. So we can take the histogram for such image, like here. We can concatenate each of the channels, and we can index it in a vector database and use it for similarity search, right? Any questions? Or you can. Okay.
How do you embed colors?
For each pixel in an image, you have a value, right? You have RGB value. It's a numeric value. 3 values. So you can take all the red, all the green, all the blue, concatenate to a big vector, and index them in vector base.
So it's a 3-dimensional graph?
Histogram is, you could say that a color is 3-dimensional, right? If you look at RGB or stuff like that, but you don't have to look. You can flatten it up, right?
That is not enough for similarity search, image search. Not enough.
Not enough for what?
For similarity search.
For like, you mean like semantic similarity, but for image similarity, it's pretty good.
No, what do you think about image similarity?
But technically, if you will shuffle the pixels, it will be the same histogram.
You're correct. This is true, but again, we're looking at the last step of the recommendation. We already know the footage. We don't want to find a similar footage. It's not a search engine. We want to grasp the essence of color of such image. This is the. So we were talking about calculating histogram, but then we encountered a problem of the RGB color space. Okay, so the RGB color space is probably the one that most of you know. Is the one who uses like digital screens, cameras, and web for representing colors. And actually, every color can be represented in every color space, right? But the thing about embeddings, when we look at the embedding space, we want to grasp the relative distance between colors. And when RGB, the problem is that it's not non-perceptual uniformity. Anyone here knows what is non-perceptual uniformity in colors?
That your eye is sensitive more to the green spectrum.
Exactly. So apparently, this is something new I learned as well, is that there's there's a subject or a keyword in color space that's called perceptual uniformity. It's the uniformity of how the human vision perceives color. It means like if a color space is perceptually uniform, it means that an addition in a numerical range in such color space will be similar to the addition of the change of how the eye perceives that change. Okay.
I'm colorblind.
Yeah, exactly. So RGB is not uniformly perceptual uniformity, but lab is trying to be. Okay, I don't think there is one color space that actually has perceptual uniformity, because it's a really hard, really hard thing to ask from a color space. Okay, but lab is a color space that tries to be perceptual uniformity. So we try to use this one and try to see if we can use this color space to measure the relative distance in colors between images. And after we did that, so we have like now a histogram of the image based on the lab color space, and now we can ask ourselves what actually we want to do with it. So like looking at it, why some fields looks better than others, we saw that there's like the subject of complementary colors and triadic colors. So complementary colors, it's actually colors if you put them together, they will pop each other's out. And so they will make like a red image next to a green image will look much better than a red image next to a purple image, for example, because they're complementary. And triadic is it's another theme that you should look for. It's the triangle of colors. So the triadic of yellow it's green and purple.
But there's 4 sections. Maybe triadic there are 4 sections.
No, I mean if you take a colors, it's triadic. It's the
120 degree shift.
exactly. Okay.
Okay, one
And
is
complementary is 180 or 90. And the complementary is 180 or
It's 180.
okay.
Okay. So this is just like how I say that? It's just like a theory in color theory that says that complementary colors looks nice together, and also 3 colors in triadics also looks good together. Okay, you can read about it. I'm not a color expert at all. So let the fun begin. For examples, so if we'll take this image, which the screen is not so good actually, but which is like the colors scheme of it is a bit like red, yellowish, and warm, and we'll calculate the complementary vector of it, and try to query similar complementary in RGB and in lab. This is the result we'll get. So you grasp with me what we did? We took this photo, we calculated the complementary image of it, we calculated the histogram, and we went to our vector database and tried to find the most similar images for this user in our database. So if you'll see, it was like this kind of like colors here, and we actually got something blue, which is nice. But if we look at the RGB, we got like nonsense, yeah, because it took he perceived very good like the darkness and then gave us just light things, but he didn't perceive the relative distance in colors.
But in your similarity, you did not use this parabola which you showed in previous slides.
What?
Can you show the previous slide? No. You can use this function for your distance. You did not do. Done.
I'm not sure I understand. Maybe you can come later.
You can normalize the values of RGB. You know what values translate to what values.
Yeah, I did a complementary of the RGB, and this is what I got. This is another for the lab colors. This is the query image, and this is similarity results, which we can see that similarity image is pretty good in similarity in terms of colors, not in terms of the essence of the image. This is another example, which I think is nice. But then we encountered a problem, because first, like I already told you about triadic, but first the first approach was said, okay, let's take the photos and find the complementary. And then we, again, find the complementary. And then what we got is actually like the chessboard problem, what we call it, which is also not really visually nice, because we see like we have a green and then a purple and then a green and then a purple, and actually there's nothing to end it. And here again. So moving in the color space. So our idea to solve this thing was, okay, triadics are like thirds of images that looks good together, and the complementary looks together. So let's just do like some very naive random walk, okay? So we take an image, we calculate the complementary or the one of the triadic. And then the same, let's calculate randomly or the complementary or one of the triadic, and then we get like a nice feed of all the colors. So this is like some nice results before I finish and let you ask questions.
The photos, by the way, of the actual one with royalty, or generated by some sort of an LLM?
No, so actually what Artlist does is they have like a content creators that create the footage for them, and you subscribe and you have like access to all of the content they have, and you welcome Artlist for me giving you like a nice marketing speech.
So Artlist uses Argmax's services?
Exactly. So just like a summary for thing, like I think Uri told me that a good meetup talk is gonna, if you guys have like 3 keywords to look for in Google. So for me, it's the lab space instead of RGB space. For us, it was new and it was interesting. The second was the chessboard problem. Okay, this is not something you're gonna look at, but be aware of. And And the ability to do like the trade-off between complementary, triadic, and moving in the color space, which also was new to us and interesting. That's it. I don't have another slide for questions, so go ahead. You got no, this one. Yeah, in the back. No, in the back. It was for you.
What was your research process for finding all this information, like the lab space and the complementary and triadic?
Okay, so actually the way it works in Artlist, which is, I think it's amazing, we have like the recommendation problem, but they also have like a huge content team that are like actually the ones who needs to say this is good enough or this is nice enough. So we had a lot of talk with them about trying to understand why they perceive something as beautiful or not, which is not like mathematical, right? Because he's gonna tell us like, yeah, this is good enough, this is not good enough. Like we actually generated a lot of samples for them and sat with them for hours and try to understand why do they think some feeds are nicer or not. And then when we suggested colors, we started to talk about colors. It's not the only thing, yeah. We did like some work also for frame type and close-up and trying to detect composition, but this is like out of scope and it's still ongoing. Other questions?
Yeah. Did you try other methods to tackle this problem? Like, because this sounds very classic, very naive, maybe. There could be some more...
Yeah, so actually we do have for each image like embeddings for it, like calculated by clip, if you guys know it. So we do have several steps before it. So like after we get the candidate generations, like the things the algorithm, the recommendation algorithm outputs, we also like perform stuff on the clip embedding themselves to distinguish like semantic similarity between images, because they're also part of the requirement comes from Artlist that the feed's gonna be diverse. So it could be that the colors are perfect, but it's like we have an image of a mountain and an image of a forest, and maybe this is not the type of diversity we want. Maybe we'd prefer to cluster them together and choose only one. So this is like a step before the color re-ranking. This is like the last step. So it's naive, but it's supposed to be naive, like in my opinion.
Maybe this is the way you did from the approach of sound. Sound is harmonic. So if you take all the histogram and combine them together and you get some sort of a harmonic distribution. This is what you did, or this is another approach of taking the data and convert it into something that will be meaningful?
Well, I'm not sure I understood actually.
You have for RGB, you have a histogram.
Yeah, for each color.
For each color,
okay.
Yes. If you take it and make it some sort of a harmonical distribution, meaning that for each point you addition each of the elements of the histogram, and you get one histogram that represents all the RGB. Mm-hmm. And that will be some sort of, let's say...
Like a representation of the image.
Representation of the...
I didn't try it, but it could be interesting. I agree. I didn't think about it.
It's not part of the talk, but you did, like, it's connected. You are ranking the photos, like the collage of photos, with composition, color, and everything. But how it's connected to the actual generating algorithm?
Yeah, you're right. Because
I assume they don't generate like not 3D, but like millions of grids, and you want everything.
Yeah. So you're right that I am missing one part of the thing, that we're looking at like, let's say we can also always look like the candidate generation process. Like, let's say we're gonna take the top 100, and then all these colors games are happening within this very like limited amount of footage. So you're right, like ideally, or not ideally, but it could be that there's not like a real complementary. But that's the thing with similarity search, that it's like we'll get the most similar out of the, I don't know, 100 photos that we index for this user.
Oh, so they already give you the photos, but what do you do with the ranking? Because you use the ranking to change the photos that are recommended, or you only rank them, and what do you do with it?
So what we did, we created like a process, like iterative process that's not taking into account only color. This is one of the feature it takes, and said, okay, I will prefer you if you're more personalized, if you ranked higher, but I will penalize you if the image next to you is like of the same color. So this is like an iterative process that in the end converges to some feeds. So we may like penalize the second most personalized image and prefer the fifth one.
Oh, so you take a subset of them.
Exactly. We take like the top 100, I think, yeah. We take the top 100 and then we rank them. We weight in them to be like prefer more personalization, but we will penalize if we'll see like a bad color match.
Yeah.
We have time for one last question. Is there a reason for the particular choice of LAB over other chromatic spaces?
So also, yeah, this we did by eye, because also there's like, I think HSL and CMYK, also like perceptually uniform, I think, or trying to be. But like just from looking at a few examples by eyes and also talking with another guy at Artlist that had experience with it, we chose lab. But yeah, you're correct that it's not like the only color space that could be fit. Okay, that's it.